After creating a disk, as shown in the first video, we can use it to create a roughing pass. The first step being to create and prepare some drawings. We'll need 3 pieces of geometry: a side profile, and a liner arc for it to follow, and a material to cut it out of. I'll start by drawing a side profile. I usually draw a rectangle representing the size of the side profile, and then I can offset construction lines for key points that I can snap lines and arcs through to create the shape. I typically don't want to cut the part out until all the profiling is done. Therefore, I won't be using the sidelines. But before I delete them, I'm going to capture and record their lengths, as I'll need them later in the video. Next, I'll draw a material, which is just a rectangle drawn in its location and to accurate size. And then I'll offset the front edge of the rectangle to become a geometry for my side profile to follow. I'm going to offset it in 1/4 of an inch so it has a nice clean cut on the edge. Since this is the line that our profile will follow, we will need to raise it in the Z, the distance of the sidewall on our profile that we're referencing from. We chose to start cutting at this end when we set tool direction. And since we deleted the lines representing the edges or walls of our profile, we'll have to raise that geometry line up by the amount of the edge that we referenced from. We'll do that by going to the Edit tab and then choosing to edit in 3D. Now, when we go to choose Move and select the geometry, it will show up as an X, Y, and Z. So I'm just going to enter 3 times for the base point, and then I'll enter 0 for X, 0 for Y, but I want to change the Z to 0.2. We can verify that the line was raised in the Z by going to more of a front view. And now, with my 3 pieces of geometry drawn, I'm going to prepare them. I'll start with the material. I'll go to the 3D tab, and then I'll choose Set Materials. And as prompted, I'll pick the geometry to become the material, and then Finish. Now, the only field that I'm going to fill out is the material top. My material is 1.25. Remember, the profile height was 1.2. And I'll check Delete Original Geometry before I say OK. I'll set tool direction on my other 2 drawings to prepare them. I'll go to the Machine tab and then choose Tool Directions. Under Open Geometries, I'm going to change the direction to reverse and the side to either left or right. I'll use left for this example. When I click on the line, it reverses direction. It is on the left side, but going the wrong direction, and also on the wrong side of my profile. But if I click it again, it will reverse the direction and be on the correct side of the profile and the direction that I want, starting at the lower side first. I also need to set tool direction on my geometry line, which will also reverse by clicking on the line. I'll click it again to go this direction because I want my profile to be cut on this side of the line. We also find that we get the best results if we use left on the profile and also left on the geometry, or right and right. And now, with our geometry prepared, we're ready to input cut information. We'll do that by choosing Cut with Disk, which will open the Select Tool window if we haven't already chosen one. I'm going to choose the 14-inch profiling blade that we made in our first video by double-clicking on the name and then clicking anywhere in the drawing to make it active, so it can open the Cut with Disk window and we can input our settings. On the first General tab, we'll verify the tool is correct. If not, we could choose Change Tool. We'll have the strategy be set to vertical for our roughing pass. Then we're going to pick the geometry, which is the line that we want our side profile to follow. And we'll click on the Pick Profile button so we can select our side profile. And this gives us a rendering or shaded view of our part. We can edit and adjust our toolpath from this window. The reverse checkbox will reverse the direction of the cut, but it will not change the rotation of the blade. The Attach at Start Point is checked, which means that the start point of the profile that we set with tool direction will be attached to the start point on the geometry line that we set with tool direction. And if we uncheck it, it will use a start point at the other end of the profile. Choosing Flip will flip the profile to the other side of the line. On the next tab, Levels and Cuts, the first setting is Safe Z Level. This value is referenced different than most other cut functions in AlphaCam. It references the center of the arbor to the table. So if I'm using a 14-inch diameter blade, its radius would be 7. And if I'm cutting 1 1/4 inch material, and I would like a 1-inch safety clearance, the value of those two added together is 2.25. I would add that to the 7-inch radius of my blade to get a grand total of 9.25. And this is the value that I'll enter into my Safe Z level. I am going to leave a small amount of stock to be left, maybe 30 thousandths, and then we'll go through finish passes in the next video. For the width of cut, I'm going to enter a value that is slightly larger than the kerf of the blade that I'm using. This will likely leave ridges in my roughing pass, but it will reduce blade deflection. The depth of cut field can be used if I want to limit the depth of each cut. I'm going to enter 1 1/4 inches so that I can cut the full thickness of my material if needed. Cleaner cut can be used as a method to add an additional finish pass to each of the cuts. If I were to use it, I would set the cleaner cut depth to 30 thousandths to remove the stock that I left. And I can also change the feed rate on that pass. I can and will use bidirectional, so the blade cuts both directions. I won't use finish pass on this roughing cut, and I'll cut the walls later after my finishing pass. And I'll set my max error on geometry to about 10 thou to make my part a little bit more accurate. And I'll leave the cutting order by depth. Next is the Lengths tab. The length is the distance that the center of the saw blade will drop in from the end of the geometry line. I'll just use this small amount, about 1.5 inches, to go past the end of my cuts for both the lead in and the lead out. And a roughing pass will already feed into the material, so we don't need to use feed between lengths. And the last tab is Tool Data. Here we can see all the information we input when we built the tool. We can adjust any of the settings if needed before we click OK to apply the cutting parameters to our toolpath. And now that our toolpath is applied, we can view it in simulation. If you do not have your Simulation Project Manager panel turned on, you can turn it on by going to the View tab and then going to Show Project Manager and then choosing Simulation. And then press the Solid Simulation button and then Play to watch your material being cut, adjusting the speed if necessary. And if you're satisfied with your roughing pass, you can close simulation and either send it to the machine or create a finishing pass, which we'll cover in the next video. Thank you for choosing Park Industries.